Good morning, everyone.
Good morning.
So much happening in this space. Peter, you've been in this space a while. I don't want to say how many years, but probably 500,000 people have read the textbook that you and Russell wrote, and 200,000 people signed up for this first MOOC on AI, and maybe 10-15% even finished it.
Yeah.
What's new? What's happening, and what's the future?
So you're right. I'm an AI hipster. I was doing it before it was cool. And now we're enjoying an exciting moment. I ran into Sergey Brin the other day, and he said, so do you feel vindicated about this AI stuff? And I said, no, Hinton and LeCun should feel vindicated. I wasted over a decade going down the wrong direction for AI. But now we're in a good place. And you know, in 1980, I was a grad student, and I was writing natural language processing programs by hand. And I always thought, at some point in my career, I will have a real conversation with a computer. But I didn't think it would happen the way it did. Right? So I thought it would be on a specific subject. We'd build a conversational agent to talk about chemistry, but you couldn't ask it about Taylor Swift. And I thought it would be limited in that way, but here we are in this amazing place where we train it just by showing it language and then doing a few tricks Joe was talking about. So I'm wearing this shirt here, which is the cave paintings in Lascaux, because I think that's where it all started, right? We decided as a species we're going to start recording what we see in the world. And I think this written language became mankind's greatest invention. And now, through the magic of GPUs, we've learned how to harness it.
So I remember back when Peter and I were both at Google Research, I gave an interview to the Register when I was in the UK at the Google facility in London. And I was asked whether there would be emergent AI, that it would just sort of emerge. And I said no. In about 2012. What I said is we saw a long path, and many of you were there, where you could see that you could continually improve things. We had an agenda we could still have been on, where we would have been improving speech and translation and summarization and image recognition and all these things that have become now essentially solved problems in much of it. And we saw that path, but none of us saw how the LLMs would sort of magically do more. And that is indeed what happened with transformers and everything else that's happened since then. There's an immense amount of change, though, going on in this, as you see, whether from the talks today. I think if there were two things that I got out of them, one is that we are continuing to chip away at the quality and affordability and efficiency of the models. And all of those things are happening. You see that, say, particularly as we talked about, say, the details of Llama and all the training and all the other models that we have. So that's one thing that's clearly happening. The second is that we're figuring out how to apply these things in many, many more domains. And I think if there's any difference in this technology versus the other revolutions that have happened in computing, whether the PC, is that it's essentially limitless in how we will apply these things. Do you see any limits at this time?
I think we're limited by data, right? And so the good applications we've had have been ones where there is some data you can use, and it still takes some expertise to be able to figure out how to make a system work. If you do it the wrong way, it's not going to work. But we're just making it so much easier that it used to be there were only a small number of experts who could make this happen. Now I think, you need expertise in building these systems, and you need expertise in the domain. I think now someone who really understands the domain but only knows a little bit about systems programming or whatever can now be successful. I think that's new. So it was mentioned that we wrote this book together on data science, and I think there's still lessons there. That's more a hands-on approach than this AI approach. But Alfred, you want to go over sort of the rubric that we came up with for how to build these systems?
Right. So when we wrote this book called Data Science in Context, and it's really about data-driven methods in context, whether you call them AI or data science, Peter and I and our co-authors, Jeanette Wing and Chris Wiggins, we all sort of thought through this topic that having a model is not in itself enough to do something useful, right? There are too many other things that you have to think about. And in fact, even our experience a few years back, it was, and sometimes that was not the bulk of the project. In fact, it usually wasn't. There were many more things you could consider would be useful or valuable than you could actually do because of other exogenous issues. So what we put together was a rubric or a checklist for the collection of things that you need to think about in order to apply these data-driven methods effectively. I teach a course on that at MIT that's very well received now, and I think it's useful, so I guess that's what we should describe. So the first is, do you or should you have the data? And I remember when we were discussing this, Peter, you said, boy, you used to think when you were early at Google, the more data, the better. But we should know better by now. Data has a cost. Mm-hmm. So there's a cost, there's a risk associated with it, there's regulatory issues with it, people are uncomfortable, all for good reasons. So do you have or should you have the data? And we don't. For COVID, we didn't have it to understand how transmission worked and such, and that led to all sorts of issues. Second is there a model? So there are many things which may not be predictable, right? So it's probably not really predictable what interest rates will be at the end of next year, right? There are too many things that happen. So I've been in finance, I've been in an algorithmic hedge fund. We don't try to do that. There are other things that are predictable. So are there models for it? And can you afford the models in execution? Third is, can you meet the dependability that now that these applications are doing really important things, will they manage privacy properly? Will they meet security goals? Will they operate when you really need them to operate? Will they not be subject to ransomware and all the other things that we see? Will they be subject to abuse? Remember, some of these systems, particularly the ones that are facing on the web, people will abuse them, whether other nation states or just hackers, they will abuse them, and then they will cause real problems if they're abused and trained in bad ways. And finally, there are really interesting problems. Will they be resilient? Do we understand them well enough? So those are the first three rubric elements that are sort of things we all need to consider, whether we're using the latest in Azure or Google or Facebook or Amazon technologies. Those things all need to be thought about because it isn't just the platform that manages all that. The next thing is, when we build these applications, do they need to be understandable? And what we mean by that is, well, first, do they need to be interpretable by developers? They need to be explainable to people who are using them. Like, why are you getting this recommendation? And do they need to be auditable? People are now very interested in whether we can go back in time and see why decisions were made, whether this was kosher or legal or something like that. Second is, a lot of the time now that we're swamped with data, we all see this, there's the notion that occurs, and probably a very large percentage of all the reporting, that if you see some association, it's causal, right? That X causes Y for some of the complicated reasons in that. And we have to be very careful that if we're really trying to show causality and like looking to do drug development or understanding disease, that we really use the most modern techniques and perhaps trials of various forms to do that. So that's a second thing we need to think about. When we're learning in science, there's all this data that people are using. How do we know we can trust the results, that there's not some mistakes or fraud or whatever? So must the things be reproducible? And we've been talking now at MIT with some of my students, maybe the systems also should have transferability. They should be teaching humans what they're doing so that we are, as humans, not left behind. So we're almost through with them. The next one is, do we understand the objectives? So it's sort of easy in a sense to say, well, gee, I'd like to have a recommendation system that recommends restaurants that you like. Well, what does that really mean, right? What restaurants do we like? Something that maybe we've never had before? That's a little risky, but maybe that's a good recommendation because we should be expanding literally our palates, I guess. Or maybe we need something comforting. There are all sorts of complexity, and that's at the root of a lot of the debate that's going on now on regulation, is what can we recommend, what can we not, what's the objective of the system, what's fairness mean? So that's the whole fairness topic comes under that. We can do things most easily in the 6th rubric is when failure is not so serious, when they're fault-tolerant applications. So those are the easiest things. That's why advertising was such an early user of machine learning, is that if you put up an ad and people didn't click on it, it wasn't the end of the world. That's not as easy for probably Waymo, where it's not a very forgiving machine learning and AI application. And then finally, we do need to think about all the societal implications. Those are more than ethics, I emphasize, although that's very important. There's nation-state politics now involved in this. Who's going to win? What's going to be the impact on geopolitics? There's interest in economics. Do these systems create wealth? Do they create wealth in the ways that we like them to create wealth, with enough fairness and some appropriate interaction with the Gini coefficient? So this is the rubric, and I think now that we're working in a domain that's so absolutely critical to the world, we're not just playing to show things work. We need to think about all this as an analyst, and as we think about analyzing these applications. And Peter, you want to comment on this as well?
Yeah, I think that's right. You know, I spend a lot of time mentoring startups on machine learning. Is something I enjoy. And coming in, it's so often they'll say, oh, you know, there's this part where we have to build this AI model, and it's complicated, and there's all this matrix math, and there's partial differential equations, and that's going to be really hard. And I tell them, no, that's not going to be where it's hard. And then a few months later, they come back and they say, oh, you were so right, that the problem is the whole workflow of gathering the data and marshaling it and curating it and then serving it and all of that, and the AI stuff in the middle, that's the easy part. And I definitely resonate with this idea of the objectives becoming important. So, you know, I see these stages of, in the early days, AI was about algorithms because AI was part of computer science, and computer science was about algorithms. And then we transitioned into this era of big data, in which we said maybe it's more important to get the right data than to get the right algorithm. And now it feels like we're in this era of objectives, where everybody's got the data and the algorithms and the GPUs, but it's figuring out what it is that you really want that's hard. And as a society, we've got lots of fables that talk about that, right? So King Midas expressed his objectives of what he wanted, of everything he touched turned to gold, but he got it wrong. And, you know, and the genie and the deal with the devil, we're always stating what we want wrong, and we're being reminded of that. But we have some tools to do that, right? King Midas should have said, well, I want everything I touch to turn to gold, but I want an undo button, and I also want a pop-up that says, are you sure, when I'm going to do something dangerous, right? So we know how to do those things, but it's hard to get it right. And I think we've built this system of on the internet for what we can click on, and it's not really serving us as a society properly. And I think, you know, we're moving now from saying we need engineers to saying maybe we need philosophers to figure out what these objectives are. And I note one of my favorite philosophers, Professor Mick Jagger, said, you can't always get what you want, but you get what you need. But I think he got it backwards, because we have this amazing system in which every click is expressing what we want, but it's not what we really need, right? So what we want is we get sold more of this shopping stuff that we clicked on. And not only is it bad for us, but everybody else gets infected with that too. And then we said, man, I wish I had those hours back that I played playing that game, but it's too late. And now we've made recommendations for all our peers. But we don't have a good way to say, we want to end hunger and we want world peace and so on. So I think we need to rebuild our systems to say, let's get away from this short-term rewards for the things that we clicked on and said we wanted right now, and let's build a system that allows us to get this sort of longer-term needs. Let's try to get that right.
So one more round of applause if you think Peter should do a cover of Mick Jagger's song with the words reversed. I would like to
Maybe we could have an AI-generated system to do that.
Someone should do that and send it to us, and we'd like to see it. Any case, so this gets to a very interesting question. So we've created a world we can measure almost everything almost all the time, and the easiest things to optimize are when they're very near term. Right? It was much harder to optimize Go with a very long-term state that you had to get to at the end where you won. It's very easy to optimize clicks. So what we're sort of saying is, well, the easy thing may not be the best thing. But now the question is, what is the best thing? So we mused, should a entertainment system know that some student has an exam the next morning and tone down the cute cat videos? It's hard enough for a parent to go into a child's room and say, stop watching videos and study and do your homework. Do we really want Facebook or Google or LinkedIn or whatever to be telling us this? So it's going to be very interesting, and I think Peter brought up the notion of philosophers in this. What I've been writing about recently is that I think the liberal arts more broadly is what we need to be educated in now to think about some of these really complicated topics. So what I've been even advising some of my students at MIT is that when they do their distribution requirements and they have 8 courses they need to take in the School of Humanities and Social Sciences, even at a very technical and scientific institution like MIT, that they take courses that will educate them in understanding democracy and autocracy, and understanding notions of economic optimization and the impact of that on perhaps the Gini coefficient and distribution of income, and all these sorts of things from historical perspectives. How much right does government have to regulate things versus individual freedom? These are age-old questions that have been going on for, I think, forever, right? Since the ancient Greeks, for sure, have been thinking about these issues. Now that we are building systems that are behaving increasingly like people, it's inevitable that these debates are going to occur on our own systems. So I would recommend everyone first take a deep breath. We're going to disagree with each other on these topics because we've traditionally disagreed on them. It's going to affect our world, and we better all be civil and recognize that these are not simple issues to resolve. But we're going to see that now, and we see it, I think, at this very moment. I think just in one aspect of it, I think Governor Newsom in this great state of California has a bill on his desk, and he has to decide whether AI as AI is regulated in a certain way, sort of with the notion that there might be existential risk, whatever, I'm not exactly sure what that means, but he has to think about that, and he's being lobbied from multiple directions on this point.
Yeah, I think that's right. And it is really difficult to come to agreement on what it is we want as a society, because different people want different things. And I think it's just more pressing now, because it used to be we could just say, well, let's be sensible and not be precise. But when you build an AI model, you have to be precise. Now, 200 years ago, Judge Blackmun said, it's better that 10 innocent men go free than that, or 10 guilty men go free than that one innocent be jailed. Now, I don't think he meant that as a constant, that, 10 is good, 11 is bad. It wasn't so precise. But with today's models, you do have to be precise. And that's something new, that we haven't had that before. We used to be able to say, use your judgment in each situation. But now we have to predefine what that judgment is, and I think that's hard. I see a sort of a multi-pronged approach. So yes, Governor Newsom has to make this choice. The White House had a set of AI principles. I don't think the answer is going to come from any one place. I think it's going to be from multiple sources. So I would like to use as much as we can existing law to say, let's not have AI law. Let's just say, if you do something wrong, you're liable for that, and it shouldn't be any different if you do it wrong with AI versus do it wrong some other way. I think a lot is covered by that. I think a lot is covered by self-regulation from the companies. All the big companies have their sets of AI principles now, and they have training courses and so on. I think that's great. I think there's a role for third-party certification. So I joined an AI safety board with Underwriters Laboratory, and I thought they were interesting because the last time there was a public scare of a technology that was going to kill everybody, it was over 100 years ago, and it was electricity. And Underwriters Laboratory stepped in and said, we're going to put this little sticker on your toaster that says it's probably not going to kill you. And consumers trusted that, and because the consumers trusted it, the brands voluntarily submitted to this certification. And I think these third-party nonprofits can probably be more agile than governments can. So I think there's a role for them. There's a role for professional societies. ACM and IEEE and so on have their sets of AI principles. We've sort of been low-key on that in the software industry. So I get to call myself a software engineer, although I don't have any official certification, and I can build any software I want. But I couldn't say, you know, I want to rebuild that bridge out there. I'm not allowed to do that unless I'm a certified civil engineer. And maybe there are some uses of AI for which there should be that kind of certification. And then finally, consumer advocacy. Right? So it's up to the consumers to say, here's what we want and what we don't want. And they can help guide where we end up. So I don't think any one of these regulatory agencies can do it, but we've got to put them all together.
And there are many reasons for that. So if we tried, even if we thought we had the world's most enlightened and perfect top-down government in the US and we all were willing to abide by that and thought it would be perfect, we're a national border. Right, so what happens in some other place, right? So we would already be at risk of that, and we saw that, say, when the EU passed the right to forget legislation. You only had to go to a non-EU designated domain, and the right to forget wasn't actually operative in that. So that's an example of where something like Underwriters Lab can be far more useful because it can cross nation-state boundaries and such. But I do think I agree with Peter. It's such an important issue. I think we probably should be changing the narrative away from regulating AI, and AI is a set of algorithms, right? Or regulating algorithms to regulating the application of algorithms in a particular context. And that's very relevant, right? So we regulate heavily automobiles when we drive them. Right? We're supposed to be on a certain side of the road. I don't know how many pages we've all internalized of regulations. That's probably 99% of what we need to do when we have self-driving cars, abiding by reasonable rules of the road. There might be a little bit more on liability that we have to think about. Maybe it's a little bit different in that instance, but it's probably 99% what already exists. So if you think about that in the regulation area, then it's the context is key. Right, so it's what's the application, what's the sector that we're operating within, what are societal norms? It's going to be different in different parts of the world, and it's just the way it is. And it's not that we're right and they're wrong, or vice versa. It's just different in many cases, and even over time things change. Privacy was initially not very much worried about. I would say when the internet started, people didn't think much about it. And now it's become a much bigger topic for various reasons. So context in time is another part of this as well.
Okay, 1 minute next. What's new and what's next? What's the one thing that you would focus on?
Well, I think I've talked a lot about over I guess 22 years since World Wide Web conference in 2002 on what I called the combination hypothesis. And that was because the team I worked with, that I had the joy of leading at IBM at the time, we had semanticists that were there, we had people interested in syntax, and we had people interested in data-driven methods. They weren't exactly machine learning as we think of them today, but they were close to that. The teams didn't get along, right? They really didn't get along. They all pursued independent paths. This was very typical of AI. It wasn't just IBM at the time. And it always seemed to me that there was some combination of approaches that would be what actually continued to push the ball forward. Well, to be frank, it's been mostly the machine learning side so far. But even there, I think we're specializing now in these agents. And we're building more specialized systems that somehow or other can combine and bring together different points of view, different amounts of expertise and the like. So I think combination works. And I think also there may still be a role for symbolic kinds of manipulation or other more structured information, just like we will want to access databases which have structure. We do access them in RAG and other ways of getting at information. So I think that's where the action may be around this and agents and combination of approaches. What do you think, Peter?
I certainly think this combination of agents is really important. In terms of an application area, I'm most excited about education, that for the first time we can really have an individualized tutor and maybe do a better job than this 1:30 or 1:50 teacher to student ratio. And I don't want the teachers to go away, but I want these tools to make the teachers better and make the students better.
So you've been saying this for since I met you in 2007.
But now we finally have the tools to do it, right? The last time, a decade ago, when I tried, the best tool we had was YouTube, and we made do with that, and we had a tiny bit of reinforcement learning, but now we have something that really is the right tool for the job.
And what I did ask you, I think, is so when we can do this, we'll have to decide what we really want to teach, which gets back to objectives. So do you know the answer to this? How important is it that we really learn in depth all of the tricks of doing integration in our first calculus class? How many of the people remember this? Relatively few. Some that in the first row, someone is smiling and waving their arm around. It's very good. But in any case, I mean, that's an interesting question. Are we learning it to understand rigor and to understand models and what a genius Newton was, or are we doing this to learn a skill that we can do over and over again, which of course can be done by a computer far better?
Yeah, well, I want the average citizen to understand reasoning with uncertainty and probability. I don't think they need to learn how to integrate. I think Wolfram Alpha does a great job of that. And the reason we taught calculus is because we wanted to teach this idea of doing proofs and doing multi-step reasoning that has different possibilities, and doesn't have to be through calculus. It can be through lots of other subjects.
On that side, I mean, the broader question I think it remains, and that is, if you learn another language, are you learning the language so that you can converse with people, or will we be using the online systems to do that? Are we learning the other language to understand culture? Are we learning the other language to understand the structure of language? All these questions are real, and I'm hoping we can actually begin to have a dialogue about that, although it won't always be so simple with many constituencies having different points of view. One of the specifics, though, in our book, and then later on, Peter and I and our co-authors, after some discussion, actually did suggest that in high school, rigorous data science and in some programming might be more valuable for most students than calculus now. So that put us in this very now politicized debate. Although we don't think it should be politicized, we think it's just completely sensible that now these more discrete kind of models based upon data are more useful for most people, and understanding statistics and those things would be more useful for most people than the calculus.
Yeah. All right. Been
All right,
great
everyone.
chatting with you.
Thank you very much.
Thank you.